two examples we will cover. These are very simple. First of all, steady state thermal. Steady state thermal, it is analogous with static structural. In thermal analysis, we will get temperature distribution, then thermal gradients, thermal flux. These we will see. A few examples we have seen in this APDL. Are you getting? Here we will draw a simple model. I will tell you how to take new plane in this. Suppose I will draw one rectangle here, which is a hollow rectangle. This rectangle I have drawn now, and extrude this rectangle. Extend we will take 10 only. Generate. Okay. Now this is extrude 10 length. It is very less. I think. Instead of 10, we will take 50 meter. Generate. Okay, now this is a rectangle, and suppose I want to create another rectangle on this surface. Are you getting? So in this case we have to take new plane. So how to take new plane? Here you can see this option, new plane. In CATIA software, in SolidWorks, you know how to take new plane. So here also you can take new plane and the location of new plane, or you can select this surface. Are you getting? Type of the plane from the face. Okay. So I will select this surface. Are you getting? So on this surface new plane is created. Apply. Okay. And click on generate. So new, you have to select new plane, then go to look at face, and once again we will draw another object. Suppose I will draw one circle now. I will draw this irregular circle here, and once again extrude this circle. Instead of this we will take 20 meter. 20 meter in reverse direction. Are you getting? Generate. Now it is generated. Reverse direction, I think it is wrong. So we have to select normal only. Normal. Generate. Okay. Now it is okay. Now this is one component. Now we will do its thermal analysis. Then go to model. So in welding problem, in pressure vessel analysis, wherever there is application of heat, you have to go for thermal analysis. Thermal analysis is also as important as structural analysis. Are you getting? Thermal and structural both are required for mechanical engineer. Any procedure you can analyze by using thermal analysis. Okay. Generate mesh. Okay. Now here we will apply some temperature inside the wall. Okay. Inside this wall we will apply some temperature. Suppose insert, or here we have to select insert temperature. Okay. So I will apply temperature. Suppose temperature it is 1000 degree Celsius. Here unit is there. Okay. And on outer surface, on this surface we will apply convection. You may know that convection always occurs on the surface. Are you getting? Conduction occurs within body. Are you getting? So I have selected this surface, and here convection option is there. So in convection, its unit is watt per meter square Celsius. So we have to give here convection coefficient. Convective coefficient of heat transfer, that approximately I will take 0.83. Approximately I have written 0.83. When you know the accurate value, you can write there. Okay. Now temperature is applied inside. Are you getting? Okay, let us see. Here I am seeing here four phases. Means it is applied all over. You can see here radar. Are you getting? Then convection is applied on outer surface. Then listen, here ambient temperature is also option. Here 22 degrees Celsius is there, I will take 30 degrees Celsius. It is also called I think bulk mean temperature. Bulk mean temperature or film coefficient. It is also called as a film coefficient. Okay. Then on this surface we will apply temperature. So temperature we will write here temperature suppose 150 instead of 150 we will apply 15 degree as it is a base 15 degree Celsius temperature. Okay. Now we will do its analysis solve. Okay. Now we will see temperature distribution initially. Insert temperature, right click, evaluate all result. So here you can see maximum temperature is 1000 in inner that is taken by it, and here you can see it is 15, and this is a temperature distribution. Getting temperature distribution. Now if you want to know temperature at a particular point, that process we know, select mesh, single select, and select this point. Okay, and create named selection. Suppose I will give name A, and insert once again temperature, geometry selection, name selection A, and evaluate. So temperature at that point is 306.88. So at any point we can get the temperature also. Similarly, we will see total heat flux. Total heat flux, maximum heat flux it is 9651.3, and unit of heat flux is watt per meter square. Are you getting? Heat flux it is similar, analogous with stress. Are you getting? Stress, what is the unit? Newton per meter square, and heat flux unit watt per meter square. So heat flux is analogous with stress in structural. Are you getting? So you can call it as a thermal stress. Are you getting? It is similar to that. Okay, and you can see its animation, thermal flux. Then directional heat flux we can see here. Now here orientation, x axis is there. Suppose I want y axis, option is available. Y axis heat flux you can see. Z axis heat flux you can see. So this is heat flux of y axis. Are you getting? Then you can see similarly z axis. Z axis heat flux. Then number of parameters are there here in thermal. Here we will not see, it is not necessary. Okay. Now reaction we will, it is not necessary. Reaction is not necessary. Suppose you want to provide heat. You want to provide heat. So you select this surface, and here option is there, provide heat flow. So you can provide heat flow. Suppose I will provide magnitude of heat flow. It is a 10 watt. Are you getting? And on this surface I have provided heat flow, and solve this. We can provide heat also. All these parameters are included. Now there will be change in these values. Are you getting? You can see here 306. After application of heat, whether it is changed or not. Once again, I will insert temperature now. Sorry, I will insert heat flux, and I will solve this. Heat flux to still change is not there. That is not affecting. Okay. Now same procedure, little bit change is there in transient thermal. Transient thermal. Now steady state means what? Temperature, heat values are constant with respect to time. But transient thermal, temperature value, then heat values, all are changing with respect to time. Are you getting? Transient structural and transient thermal. Same model I am taking for transient thermal. The both analysis are very important in all projects. I will tell you conductivity is how, what is the value of conductivity. Now this workbench is taking steel as a default material. We can change the material also. That exercise also we will do. We can change the material. Instead of steel we can take cast iron, composite material. There is a large library available in ANSYS workbench. Now you see, first of all I will do its meshing. Now I will apply temperature inside. Insert temperature. Temperature once again we will take 1000 inside. Then convection coefficient we will apply on the surface. Convection coefficient 0.83, and here I will take 30 degree Celsius. Then analysis setting it is there. 1 second, during 1 second we will get the answer. 1 second it is sufficient. Okay. This much we will do only and solve. Temperature and convection. All parameters you can apply. Radiation coefficient also you can apply. Stephen Boltzmann coefficient you can apply. Just right click on, and on the surface you can apply. But in most of the cases, radiation is neglected. Convection and conduction are considered. But radiation is neglected in most of the cases. Heat flux, directional heat flux, evaluate all together. Now its values are little bit different. Here you can see little bit change is there, and graph also you can observe. So first of all you will see temperature. This is temperature. Suppose I want temperature on this surface. Are you getting? So I have selected this surface. Insert temperature. Only that surface. Huh? So select that surface and select on temperature. Solve. So you are going to get temperature distribution on that surface only. So maximum it is 24.821. On particular surface you can get the temperature. Suppose you want temperature on the this circumference. Okay. Insert temperature, evaluate. So on this surface, particularly you can see the temperature distribution on that surface. So you can see here within blue color region temperature range is 16 to 20. In red color 47 to 43 degrees Celsius temperature. So all problems of heat and mass transfer you can solve in ANSYS software. All problems of strength of material you can solve this in ANSYS software. getting. And similarly you can plot the graphs. Plotting graph procedure, it is same, it is not going to change. Suppose I want to see thermal flux on this surface, so select this surface, thermal heat flux, evaluate all result. So on this particular surface these are the values of heat flux, and particular surface you can animate also, that surface you can animate only or read.